Today we're going to be talking about the percent of change and the percent error. These are actually two different lessons in our book, but they're so similar that we're going to do them on the same day. So if we want to find the percent of change, which is also referred to as the percent of increase or the percent of decrease, increase of course if the number gets bigger, and decrease if the number gets smaller. So we are going to subtract the numbers they give us, and that's going to be like the change or the difference in the numbers. We're going to divide it by the original starting number. Remember that whatever we get when we do the change divided by the original, we need to make it a percent by multiplying by 100. And they want us to round off, in this case, to the nearest tenth of a percent. So let's jump right in. We want to know what's the percent of change from 25 to 49. So first I need to subtract these numbers to find how much the number changed. It changed by 24. It went up 24. And then we're going to divide by the original number, which is what the number started at, in this case, 25. Then I can use my calculator. 24 divided by 25 is 0.96. And I want to make that into a percent by multiplying by 100. I'm going to get 96%. And that's it. Let's try the one next to it. So we have a decrease from 65 to 45. So you're just subtracting always the smaller number from the bigger number to just find out the difference between the numbers. So that number changed by 20, and the original number was 65. On my calculator, I'm going to do 20 divided by 65. And I get a big mess. I get 0.307692231. So it says to round to the nearest tenth of a percent. Before I round, I have to make it a percent. And to make it a percent, we're going to multiply by 100, which moves that decimal 2 places over. So it's 30.769231%. Now I'm going to round to the nearest tenth, which is the first decimal place, by looking at the one just to the right. And if it's 5 or more, I round up. So it's going to be 30.8%. And this is a decrease because it went from 65 to 45, which of course is a decrease in the amount. Let's try number 2. Susie purchased a daily planner for $32. The wholesale cost was $25. Wholesale means like a company will buy a product for a low price and then sell it to their customers at a higher price so they can make money. The original price they buy it for from like the manufacturer is called the wholesale price, and the price they sell it to the customer for is called the retail price. We need to find out how much that price changed by subtracting. It changed by 7. So we want to do the change over the original number. Remember, the original number is what that price started at. It started at 25. It is not necessarily the order the numbers appear in the word problem. You have to really read it and understand it. So the price of the planner started at 25. That's the original price. So we're doing the change, which is 7, divided by the original, which is 25. And you get 0.28 multiplied by 100 to make it a percent. So 28% is what it was increased by. All right, moving right along here. Carlos used a coupon and paid $7.35 for pizza that normally costs $10.75. Find the percent of decrease. So first, let's find out how much the price went down by when he used his coupon. $3.40 is the change. The original price of the pizza, like before the coupon, is $10.75. So $10.75. We're just going to divide those on the calculator. And getting another messy decimal. It's long, so to round it to the nearest tenth, first I need to multiply by 100 to make it a percent, which moves the decimal twice. And then when I round to the nearest tenth, I want to look at the number just to the right of it, and since it's less than 5, I keep it. And so 31.6%. All right, let's try another example for percent of change. When Bobby was exercising, his heart rate went from 79 beats per minute to 98 beats per minute. So let's see how much it changed by. It changed by 19. So what was the percent of increase? So we're going to do the change over the original, or the starting number. It started at 79. In my calculator, I'm doing 19 divided by 79, and I'm getting this. And again, I'm using a calculator, but I'm showing my work. So first I want to multiply by 100, which means I move the decimal twice to the right. And then to round to the nearest tenth place, I'm going to find that right here. Look at the number just to the right of it. Since it's 5 or more, I'm going to round up. So it's 24.1%. Beautiful. All right, now we're going to talk about the percent of error. And it's really found in a very similar way, which is why we're doing them both today. So percent error means, like, if somebody makes an estimate or a guess or a prediction, and then the number ends up being a little bit off, we want to know what percent they're off by. So again, we're going to subtract the numbers. So we can still call this change, or you can call it the error, or you can call it like what you're off by, and you're dividing by what the number actually was, the actual number. And then of course, to change it to a percent, you're going to multiply by 100. All right, let's try one. Mrs. Mandel predicts that 10 out of 30 students will earn an A on the test, but actually 12 students earn an A. What is the percent error of Mrs. Mandel's estimate? Round to the nearest tenth of a percent again. So we want to know the change, or like the error, or what I was off by, and divided by the original. So let's see. I guessed that 10 were going to get an A, but actually 12 did. So I was off by 2. That goes in the numerator. And then it says that 12 students actually got an A. So in my calculator, I'm just going to do 2 divided by 12. It's ugly. It's 0.16 forever, never, 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 never repeating. So I want to multiply by 100 to make it a percent and get, enough in there that you can round. So if I round to the nearest tenth place, I'm looking at the one directly to the right of it. Since it's 5 or more, I'm going to round up to 16.7%. So my estimate was off by 16.7%. And the last example, a package of candy should have 125 pieces, but when it's checked at the factory, there are only 118 pieces. What is the percent error? Round to the nearest tenth of a percent. So I'm going to find out how much it was off by. 7. So we want to divide 7 by what was actually in it. So there were actually 118 pieces. Let's punch that into the calculator. 7 divided by 118 is 0.05932203. So we want to multiply by 100 to make it a decimal. To make it a percent. And then we're going to round to the nearest tenth. So when we round to the nearest tenth, we are looking, this is where the decimal is, at the tenth place, and then the number just to the right of it is less than 5, so we're going to keep this a 9. So the factory has an error of almost 6%. A lot of factories have like a certain percent error that they try to stay under. I would say that's kind of a big error in a bag of candy, but there we have it. Thank you for watching.